Hello viewers, we are Gadaruna taking you through the story for O-Level Mathematics Paper 1. And this video we are going to go through the marking guide for Senior 4 Math 1 Uneb of the year 2022. So this video is suitable for students in Senior 4. So like we said, in this month we are interested in uploading puzzle parts for mock exams, and Uneb exams. So the ones for mock, which are for Senior 5s, are done, and now we are going to begin on the ones for Uneb, after which we shall go to the ones of mocks. So in this video, we are going to go through the video of Math 1 Uneb 2022. So section A, we shall start with question 1. Section A contains 40 marks and 10 questions, each with 4 marks. And we are supposed to attempt all the questions. So the reason why we are going through the marking guide for this Uneb is that it is always advisable to sit Uneb for the current year. It is advisable not to sit Uneb for a current year before looking at the Uneb of the previous year. For example, you are going to sit Uneb for the year 2023, so it is not advisable for you to just go and sit for that paper without looking at what was set in 2022. So basically that's why we are going through this video, so that you can understand what the question really required, and where necessary we shall point out the common mistakes which were attempted by students. So question 1 says, solve the equation. Then they give this equation. So you shall realize that there are brackets here. So the first thing to do is to open brackets. So when I open brackets, this 3 by 4d gives me 12d. 3 by negative 1 gives me minus 3. Then negative 1 times 3d gives you negative 3d. Negative 1 times negative 2 gives you positive 2. So that was this first step. The next will be collecting like terms on the left hand side. So this with this gives you 9d. Negative 3 plus 2 gives you negative 1. Okay. Then next we can cross multiply. Take this side, but remember to put in bracket because this 9 must multiply each term on the left hand side. So when you open brackets, this times this gives you 81d, this times this gives you negative 9. Then again you are going to collect like terms by bringing this on this side. So 81 minus 5 gives you 76d. Then this was negative 9. When it goes this side, it becomes positive 9. Next is to divide both sides so that I can make d the subject. So this cancels with this to give you d as 9 over 76. So basically that is what they wanted. First mark was to open brackets, cross multiply, divide through, and the output. So if the answer can be given in fraction form, it is advisable to leave it in fraction form. Good enough, this is an improper fraction. Then question 2 says, determine the inverse of the matrix this. So to get inverse, the first thing to do is to get the determinant. Determinant is product of entries in the major diagonal, which is negative 6 times 2, minus product of entries in the minor diagonal, which is 7 times 1. So negative 6 times 2 gives you negative 12, and there is this minus, then 1 times 7 gives you 7. So negative 12 minus 7 gives you negative 9, and that will be the determinant. Then next we need what we call the adjoint. Adjoint means you interchange the entries in the major diagonal. So where there was this 2 will come here and this negative 6 will replace the 2. I think I can see here 2 is here, negative 6 is here. That is about the major diagonal. But for the minor diagonal, you change the signs. So initially this was positive, so it becomes negative. This was positive, so it becomes negative. That's what they mean by adjoint. So after getting the determinant and the adjoint, next is to remember that inverse is 1 over determinant times the adjoint. So 1 over determinant times the adjoint, then bring this fraction this side to give you this matrix. And that's what they wanted. Then question 3 says a father is twice as old as his son. Okay. He is 5 times as old as his daughter. Write the expression for their total age. So here we have father, son, and daughter. So we have to let. So let X denote age of the father, Y denote age of the son, and Z denote age of the daughter. Then you shall remember that the father is twice. So X is twice. That's where the 2 comes in, as old as the son, and we know that son is Y. Then I will make Y the subject by bringing this to the side to give you X over 2. Then next they said that the father is 5. So father is X and 5 times as old as the daughter. The daughter is Z. So still make Z the subject to come up with X over 5. So now I know that the father is X, the son is X over 2, and the daughter is X over 5. And the question wants the total age, the expression of the total age. So you come and add all of them. Total age is X, Y, Z, but Y is this, Z is this. So get the LCM and come up with 17X over 10 as the total age. So basically that's what they wanted. You had to get the age of the son in terms of the age of the father, and also age of the daughter in terms of the age of this father. Then you add everything to come up with the output. Then question 4 says simplify this. So here, first of all, 12 and 27, 3 is common. So 3 comes out. Then to get what to put here, you'll say 12m squared divided by 3 to give you 4m squared. Then 27 divided by 3 to come up with 9. The minus is maintained. Then we realize that this 4 is the same as 2 squared. So it becomes 4m squared becomes 2m in brackets squared. And 9 is 3 squared. The reason why we are doing that is to bring in what we call difference of 2 squares, where there is a sum and a difference expressed as a product. Now this and this cancels and you remain with that. And that's what they wanted. So one was for factorizing, identifying difference of 2 squares, applying difference of 2 squares, and simplified output. Question 5 says, a regular polygon has an exterior angle of 24 degrees. Determine Roman 1, the number of sides of the polygon, and Roman 2, the angle sum of the polygon. So number of sides is equal to 360 divided by the exterior angle. So 360 is here and the exterior angle is 24. You'll come up with 15 sides. So it is a 15-sided polygon. Then also the angle sum of the polygon. Angle sum is given by the formula 180 in brackets n minus 2. We already know the number of sides, so we shall substitute where there is n, we put 15. And in the end, we shall come up with 2340 degrees as the interior angle sum. So substitution, output, each gets a mark. Then question 6 says, under a translation, point A, which is negative 2, 3, is mapped onto point A prime, which is 5, 7. Determine the translation vector. So now the translation is equal to image minus object. So image is there, object is there. Then we subtract. So 5 minus negative 2 gives you positive 7. 7 minus 3 gives you 4. And that's what they wanted. So the first mark was for writing the image in vector form. Then next mark will be, which is this. Then writing the object in vector form. Then subtraction and output. Then question 7 says, the heights in centimeters of 6 purple seedlings are these ones. Using an assumed mean of 50, calculate the mean height of the seedlings. So here I have the values of the x are the values which are given. These ones up here, which is this. Then now the d, which is the deviation, is got by x minus the assumed mean. And our assumed mean is 50. So we shall get this minus 50 to give you that. 55 minus 50 gives you 5. 46 minus 50 is a negative 4. 43 minus 50 is a negative 7. 56 minus 50 is a positive 6. 58 minus 50 is positive 8. Then when you add all of these ones, you come up with 18. Then from there, I remember the formula for mean given assumed mean. So you first write assumed mean plus summation of the deviation over the number of items, which gives you 53.6. So this was for all these values of d, then summation, then substitution, and output. Question 8 says, solve the inequality this. So this is what we are given. The first thing to do is to cross multiply so that this half 2 goes this side to come up with this. So remember to put a bracket because this 2 which has gone this side must multiply each term on the right hand side. Then next is to open brackets. 2 times 6 is 12. 2 times x is 2x. Then you realize that they are like terms. So I'll collect like terms by taking this side to come up with 2x minus x. Then this the other side to come up with negative 2 minus 12. I'm doing that so that I can get a positive x. Then from there you rearrange to come up with x is less or equal to negative 14. And that's what they wanted. So first mark was for cross multiplying, x open brackets, collecting like terms, and output. So now we shall go to question 9, which says, the pie chart below, which is this, shows the grades obtained by 180 students in an examination. Part A. How many candidates obtained grade F? Part B, what was the percentage of candidates in grade 1? So grade F is here, and it is 10 degrees of the total angle sum, which is 360. So the fraction of those who got grade F is 10 over 360. That is the fraction. But how many are they in total? They are 180. So the number will be the fraction of those with grade F, which is 10 over 360 multiplied by the total number of candidates, and it will give you 5 candidates. Then part B, they said, what was the percentage of candidates in grade 1? So grade 1 is here, and the fraction, so the angle is 72, so meaning the fraction will be 72 over the total angle sum, which is 360. But they want percentage, so I multiplied by 100%, which gives you 20% as the required percentage. So substitution, output, substitution, output. Then question 10 says, town B is 44 kilometers south of town A. Okay. Town C is 33 kilometers west of town B. Okay. Find the bearing of town A from C. So town B is south. So south, if this is A, this will be B. Then from there, they said town C is 33 kilometers west of B. So at B, go to west and locate town C. That's what they want. So let's first come and sketch it using a ruler. We shall have town A. Then you go southwards to locate town B, but you move 44 kilometers. Then from town B, you go west to locate town C, and you move 33 kilometers. Then the question wants the bearing of A from C. A from C. So you have to draw a line and locate that bearing. So theta will be the bearing they want. So I'll come here and say that using this angle, first of all, this is what they want, but they are alternating. So I can put it here. Then when I'm here, this is the opposite and this is the adjacent. Then remember from SOHCAHTOA that tan is opposite over adjacent. So I'll come and put the opposite over the adjacent. And I'll make theta the subject. So angles are to 2 decimal places. Therefore, the bearing, remember bearing has 3 digits. So it will be 036. So if you stop here, then you'll have missed the mark for stating the bearing. So B1 for the correct diagram, substitution, angle, and stating required bearing. That was section A. Now we shall go to section B, where there are 7 questions and the student is supposed to answer any 5, and each question carries 12 marks to make a total of 60 marks. So we shall start with question 11. Question 11A says, the probability that student A will pass mathematics is 3 over 5. Okay. The probability that student B will pass the same test is 2 over 3. Okay. Determine the probability that A will pass the test and B fail the test. So this probability is the probability of A and this is the probability of B passing. So B failing will be B complement and A failing will be A complement. So you come here and say, first of all, they want us to get the probability that A passes and B fails, that is A intersection B complement. So I have to get the probability of A, which is given probability of B, which is given. Then I also get the complement. Complement, I remember that probability of B plus probability of B complement is equal to 1. So I'll come and substitute and make this B complement the subject by taking this side. So I'll come up with B complement as 1/3. Then I can get the required probability of A intersection B complement, which is probability of A times probability of B. So intersection means multiplication. Then I'll substitute for A and for B complement to give you 1/5. So basically that's what they wanted. And that's why we get the 4 marks in part A. So now shall go to part B. Part B says a die has faces numbered this 10, 7, 8, 9, 7, 8, 9, 10, 11, and 12. A second die has faces labeled 1, 2, 3, up 6. During a game, 2 dice are tossed. The difference between the numbers on the first and second die are recorded as scores. Difference means subtraction. Part A, construct a possibility space for the scores. And Roman 2, find the probability of obtaining a score that is a multiple of 2. And Roman 3, find the probability of obtaining a score of 3 or more. So I'm going to start with Roman 1, where you have to write a possibility space. There shall need to draw a table having the labels on die 1 and the labels on die 2. Now they say the difference between the 2 dice, so it means we're going to subtract. For example, what to put here will be 7 minus 1 to give you 6. Then 7 minus 2 gives 5. 7 minus 3 gives 4. 7 minus 4 gives 3. 7 minus 5 gives 2. And 7 minus 6 gives 1. Okay, do the same for the next. 8 minus 1 gives 7. 8 minus 2 gives 6. 8 minus 3 gives 5. 8 minus 4 gives 4. 8 minus 5 gives 3. 8 minus 6 gives 2. Then we are going to do the same for the next until all are done, getting the differences. Then for the next, and lastly that. Okay, then the first, that was called the possibility space. Then Roman 2, they asked for multiples of 2. So in those values, we shall identify the multiples of 2. And those are the multiples 4, 2, 4, 6, 8, and 10. So you have to count all of them. There is, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it is, event is 18 over the total. Total will be, if you remove this, you have to count all the boxes. So 1, 2, 3, 4, 5, 6. Then, okay, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So it will be 18 over 36. That was Roman 2. Roman 3, they wanted probability of finding a score of 3 or more. So score of 3 or more, all those ones are needed from 3 and above. So 1, okay, let's start. Let's do column by column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Okay, so it will be 33 over the total, which of 36. And that's what they wanted. So 1 mark for the table seen with these samples, then B1 for the difference here and here. Another B1 for this pair, another B1 for this pair. Then B1 for this numerator alone, another B1 for the whole of this fraction. It is okay to reduce or not. Then B1 for this numerator and B1 for the whole of the fraction. That was question 11. Now we shall go to question 12. 12a says, solve the equation this. So I think let's start with that. So this is under indices, so we have to change. We know that 81 is 3 to the power 4, 27 is 3 to the power 3, 243 is 3 to the power 5. Then from there, we shall remember that these are both powers, so it will be this times this to give you 4x minus 12. Then 3 times the whole of this to give you 6 minus 3x. Then here it is in a denominator. To bring it to the numerator, you put a negative index. Then from there, realize that all these ones are same base. So I'm going to begin with this left-hand side, same base. When there's a product, you add the powers. Simplify to come up with that. Then same base, if there's an equal sign, you equate the powers. So I'll equate the powers, then make to collect like terms by taking this on this side and this on this side to give you 6x equal to 6. Divide through by 6 to give you the value of x as 1. So that's what they wanted in part A. Then part B, they said, so this part A, 1 mark was for this right-hand side, another mark was for this right-hand side, seeing these 3 to the power, 3 to the power, 3 to the power. Then this is for adding the powers. Then this mark for equating the powers. And this one for dividing both sides and the output. Then part B says, find the value of n when this is equal to that. So that is under changing base. So 134 in base n is equal to 54 in base 8. So at first convert everything to base 10 by giving this. So this is power 1, 0, 1, 2. That's why you see here 1 times n to power 2, 3 times n to power 1, 4 times n to power 0. Then you have power 0 and power 1. So 5 times 8 to power 1 and 5 times 4 times 8 to power 0. So in the end, we shall come up with that. So this is n squared, 3n, and 4 because the number to power 0 is 1. Then this is 40 and this is 4. So now it is in base 10. which is the normal wave arithmetic. So correct like terms, this and this cancels, then take this side to come up with negative 40. This becomes a quadratic. You can either factorize or use a quadratic formula. If I factorize, I will look for factors whose sum, two factors whose sum is positive 3 and the product is negative 40. And those factors are negative 5 and 8, because when you add these two, you get positive 3, and when you multiply, you get negative 40. So I replace where there is 3, I'll put there negative 5 plus 8 to give, but there is an n outside, so that is why you see here negative 5n plus 8n. Then pair each, get each pair. So this one alone, the common factor is n, so you come up with n minus 5. This one here, the common factor is 8, so you come up with 8 in brackets n minus 5. Then this is the same as this, so pull it out and you remain with n plus 8. So that means that n minus 5 is equal to 0, or n plus 8 is equal to 0, giving us n equal to 5 or n equal to negative 5. But because it was a base, it implies that n is not negative. So the value they want is n equal to 5. So 1 mark for changing the left hand side, 1 mark for changing the right hand side to base 10, getting a quadratic formula, another mark. Solving, you can either use factorization or bulldozer method, that is 1 mark. B1 for both values of n, and B1 for identifying that n cannot be negative. Then question 13 says, 4 traders, Akelo, Baine, Cherop, and Damba bought commodities as given below. Akelo bought 1 bag of posho, 5 bags of potatoes, 2 bags of sorghum, and 2 bags of rice. Okay. Baine bought 5 bags of posho, 5 bags of potatoes, 4 bags of rice. Then Cherop bought 4 bags of posho and 8 bags of rice. Damba bought 2 bags of posho, 5 bags of potatoes, 4 bags of sorghum, and 3 bags of rice. The cost per bag of the commodity was shillings. So for posho, 100, for potatoes, 75, for sorghum, 60, and for rice, 200. Part A, write the matrix for the commodities and for the costs. I think let's start with that. So for commodities, this was Akelo. Akelo bought 1 bag, 5 to 2. Then this was Baine, this was Cherop, and this was Damba. That was for commodities. Then for the prices, so the price of posho, potatoes, sorghum, and rice. This was for posho, then potatoes, sorghum, and rice. So they should correspond, because this is for also posho, potatoes, sorghum, and rice. So that in multiplying, you each multiply a correct entry. So here our interest was a correct order and correct entries. For Roman 1 and Roman 2, both have to be correct order and entry. Then part B, using matrix multiplication, Find how much each trader spent on the commodities. So amount spent, we are going to multiply. Remember, I multiply with row by column. So these are row, we have 4 entries. Column should also be 4 entries. Then we shall begin this with this. Gives you 1 times 1,000, 1 times 100,000, which is this. Then 5 times 75,000, 2 times 60,000, and 2 times 200,000. Then next will be this with this to give you this line, this row. Then next will be this with this to give you this row. And lastly, this with this to give you that row. So we can simplify and get the output. So when most students were doing, they would not add these addition signs. So in the end, they would end up with a 4 by 4 matrix, which is not okay. Then you can conclude what Akelo spent, what Bine spent, what Cherop spent, and what Damba spent. And that's what they wanted. For part C, they said, the traders sold all the commodities and got the following amounts. Akelo got this, Bine got this, Cherop, and Damba. Determine the profit of each trader using matrices. So there we shall subtract, but subtraction must be in matrix form. Then you come up with this minus this, this minus this, this minus this, and this minus this to give you that. Then you can state the profits. And basically that's what they wanted. Then question 14 says, in the figure below, ABC is a right-angled triangle. AB is C centimeters, BC is A centimeters, and AC is B centimeters. So BC is that, AB is C. The area of quadrant ABE is 8 centimeters squared. The area of quadrant ACD is 10 centimeters squared. Find the values of B and C. Then part B, find the area of triangle ABC, quadrant BCF. So area ABC is a quadrant, so it will be a quarter pi r squared. Then substitute the area, a quarter is here, then pi is 22 over 7, then radius was C. If you look at this, for ABC, radius is here, which is C. So when I simplify this, I'll come up with 11 over 14, then there is this 8, and there is this C squared. Cross multiply, take this 14 this side, come up with 112, then divide both sides by 11 to come up with 112 over 11. But that is squared, meaning that C will be square root of this, which is 3.1909. Then for area SCD, we shall still do the same. Radius is B, area is 10. So this one simplified to come up with 11 over 14. Cross multiply this with this gives you 140. Divide both sides by 11 and get a square root. So that's what they wanted in part A, value of C and value of B. For part B, they wanted the area of triangle ABC. ABC. Okay. Then area of quadrant BCF. BCF. BCF means you have to get the value of A. So from Pythagoras theory, B squared is equal to A squared plus C squared. Substitute for B squared, substitute for C squared, and make A squared the subject. Then you can get square root. After getting the value of A, I can now get the area because area is base times height. So base is A, height is C. So in the end, we come up with 28 over 11, which is 2.5455. Then area of quadrant BCF is still a quarter, so a quarter pi r squared. Substitute the radius is A, which you have got here. So A squared will be 28 over 11, and the area will be 2 centimeters. So basically that's what they wanted. Then question 15 says, part A, a motorist rides from home to a trading center at 30 kilometers per hour. The cyclist immediately rushes back home at 45 kilometers per hour. This whole journey takes 15 minutes. Determine Roman 1, the distance between the home and the trading center, and Roman 2, the time spent to travel from the trading center back home. So first of all, total time is 15 minutes, but we have to convert to hours because we are converting to hours because here the distance, the speed was in kilometers per hour, meaning time has been hours and distance has to be in kilometers. So let x be the distance from home to the trading center and t be the time taken from home to trading center. Meaning for the journey from home to trading center, distance is speed times time. So substitute for distance, which is x, speed, which was given, and time, which is here. Meaning you can make t the subject. Then for the journey from returning from trading center to back home, the distance is still the same, the speed changed, and the time changed. Because the total time was 50 minutes, which is 50 over 60, meaning that now if he used this t to move from home to trading center, then the balance is what he will use to move from trading center and back home. So open brackets, come up with that, equation 2. Then we know that t is this, so come and substitute and come up with an equation with only x. So collect like terms. So here what I've done, I've first multiplied throughout by the LCM, which is 2. Then I'll collect like terms, and next side we shall see how to make x the subject. So making x the subject, I have to divide both sides by 5 to come up with x as 15 kilometers. So now we shall go to part A, Roman 2. Roman 2 says, determine the time spent to travel from the trading center back home. So trading center back home, remember the time was 50 over 60 minus t. So you have to first come and get t, then we get the required time. So from equation 1, t is x over 30, but x is 15 to give us a half. Then required time will be 50 over 60 minus t, which is 15 over 30, to give you 1 over 3 hours. Then you convert to minutes, which is 20. So now shall go to part B. Part B says, Salome was given shillings 6,200, which was exactly enough to buy 3 loaves of bread and 2 kilograms of salt. However, she made a mistake and purchased 2 loaves of bread and 3 kilograms of salt. She then had a balance of shillings 400. Calculate the cost of a loaf and the cost of a kilogram of salt. So let x denote and y denote cost of a loaf and cost of a kilogram of salt. So x is for a loaf of bread and y is for a kilogram of salt. So at first the amount was supposed to be for 3 loaves of bread and 2 kilograms of salt, and it was just enough, meaning the total cost was 6,200. But instead she bought 2 loaves of bread and 3 kilograms of salt, and she had a balance of 400. So it means that the amount used was 6,200 minus 400. When I subtract these two, I'll come up with 5,800, which gives me equation 2. Then I have to solve. To solve, my aim is to make sure that these ones are the same. That's the first step. So what I will do, these 2 will come here so that it multiplies through to give you 6, and this 3 will come here so that it multiplies through to give you 6 here, which can be eliminated. So when I do that, I'll come up with 2 by this is 6x, 2 by this is 4y, 2 by this is 12,400. Then 3 by this is 6, 3 by this is 9, and 3 by this is 17,400. So when I subtract, this goes away. This gives me negative 5y, and this gives me negative 5,000. So before we go to the next slide, these are the marks for this slide. So next is to divide throughout by negative 5 to come up with the value of y. Therefore, the cost of a loaf of bread was shillings 1,000. Then from equation 1, I'll substitute for y. And make collect like terms, then make x the subject. That will be the cost of a kilogram of salt. And that's what they wanted. Then question 16 says, triangle ABC with vertices 4,1 for A, 4,4 for B, 2,1 for C is mapped onto triangle B1, B2, C1 by a transformation matrix. This triangle B1, C1, B1, A1, B1, C1 is then mapped onto triangle A2, B2, C2 by a transformation whose matrix is this. Determine, Roman 1, the coordinates of A1, B1, and C1. Then part B, the coordinates of A2, B2, and C2. And part C, a single matrix of transformation that maps ABC onto A2, B2, C2. So first we shall quote the matrix and then the coordinates, coordinate of A1, coordinate of A, coordinate of B, and coordinate of C. Then we are going to multiply row by column. This by this gives you 8, then this by this gives you 1. Then this by this gives you 8, this by this gives you 4. Then this by this gives you 4, and this by this gives you 1. Now for the second row, we shall deal with this and these ones. For example, this with this, it gives you 4, and this with this gives you -2. Then do the same for B. This with this gives you 4, and this with this gives -8. Then this with this gives you 2, and this with this is -2. So in the end, you shall simplify. This gives you 9, this gives 12, this gives 5. This gives 2, this gives -4, and this gives 0. Meaning coordinate of A is 9, 2, B is 12, -4, and C is 5, 0. The image. Then part B, there's a further transformation of this. So you are going to put here A1, B1, C1, so that you can get A2, B2, C2. So when I multiply still row by column, I'll come up with this, this, and this for row 1. Then this by column, you come up with this, this, and this for row 2. So in the end, the images A2, B2, and C2 are those. Part C, they wanted a single matrix which maps the object to the final image. So that is matrix this followed by this. And that is written by starting with the end. Then you go to the first one. So multiply this, it will still be row by column to give you this. Then again row by column to give you this. Then again row by column to give you this, and row by column to give you that. So in the end, you come up with this as the required single matrix. So note the order. Some students, when they see this followed by this, they write this here and this here. That is not okay. The last should be the first. And that's how the 12 marks were awarded. So now we shall go to question 17. Question 17 says, the points P, which is 6, 1, Q, which is 9, 4, R, which is 7, 8, S, which is 2, 6, and T, which is 2, 4, are vertices of a feasible region. Part A, show the feasible region on the graph with lines RS and ST as broken lines. So you come here and get our graph paper. Draw the axis, horizontal, which is the x-axis, and the vertical, which is the y-axis. Then get the scale for the horizontal and put the values. Do the same for the vertical and put the values. Then we shall start our plotting. Plotting, we have P, which is 6, 1, and Q, which is 9, 4. So P is 6, 1, which is there. Then Q, which is 9, 4, 9, 4, which is there. Then R is 7, 8, which is there. Then we have S, which is 2, 6, and T, which is 2, 4. S is 2, 6. Then T is 2, 4. Okay. Then we shall join, but remember they said this is dotted. So you come and join it when it is dotted. Then also ST is dotted. So join when it's dotted. The rest are continuous solid lines. So from T to P, from P to Q, and from Q to R. Because it is a feasible region, it means that the unwanted part is the whole of this area. So I shall do that. We shall shade that as the unwanted. Let's start with RS, then ST, then TP, PQ, and lastly QR. So that's what they wanted us to do in part A. Part B said find two inequalities which describe the feasible region using the lines PQ and SR. PQ, PQ, and also SR. Now what we are going to do, we are going to first get the equation of a line given those 2 points. So PQ, the points are 6, 1 and 9, 4. So let's first use those 2 points to get the equation of that line. So using those, change in y equating gradients, change in y over change in x is equal to change in y over change in x. So here I'm using 2 points, P and Q, and here I'm using a point xy and the point P. So cross multiply, expand, and create like terms by putting everything on one side. Therefore, the feasible region can be got by testing using 0.55. Now, why am I choosing 55? It is because when you come here, we have to choose a point in between inside this feasible region. So 5, 5 is inside. But you can also choose any other point as long as it is inside this feasible region. So if I use 5, 5, left hand side will be this left hand side. There is 8y 3 minus 3x minus 5. So it gives you 25. Now this 25 is bigger than 0, meaning we are going to use the inequality of greater than or equal to. Now the question is, why am I using greater than or equal to and not greater than? I'm using greater than or equal to because the line on the graph was solid. If you look at PQ, it was a continuous line. If it was this dotted, it would have been just greater than. Then using point S and R, still equate gradients, cross multiply, open brackets, and take everything on one side. Then you test still using 5, 5, 5y, 5x, and minus 26 will give you negative 11. Now negative 11 is smaller than 0. So the inquiry will be that. Now the question is, I think realize here, I'm just using less than, I'm not using less or equal to, because if you go to the graph, SR is dotted. So basically that's what they wanted in part B. And that's how you could get the 5 marks. Now shall go to part C. Part C says determine the maximum value of 2x plus 3y in the feasible region. So maximum means you look for the points at the extreme right and also extreme top. Okay, but that point should not be on a dotted line. So this point is off, this is off, and this is off. Even if it's an intersection of a dotted and a continuous, you don't include it there. So the first point will be for 7. If you look at the 7, we're interested in the extreme top. So it is 7, because when you go from here, you reach 8, which has a dotted line. Then when you go to 8 extreme top is here, which is 8, 6. Then for 9, it is there, extreme, because after that it is unwanted. So shall go with those ones. And those are the ones we shall use to get the maximum value. Remember, the expression for maximum value was 2x plus 3y. So that's what we shall use. So this, it means 2 times 7 and 3 times 7 to give you 35. Then this means 2 times 8 and 3 times 6 to give you 34. 2 times 9 and 3 times 4 to give you 30. So from there you can realize that the maximum is 35. And that's how the marks will be awarded. So before we go to the next, or before we finish, let's go and see how marks for the graph were awarded. So that's how the marks for the graph were awarded. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on S4 Math Part 2 for Uneb 2022. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.